Hello friends, this is Mukesh from Contec here again, talking to you on the EM series Dehumidifier. Now this machine, what we have just commissioned in the factory is for Sanchi Engineering at Pune. It's a 500 CFM dehumidifier consuming 48% less power than what a conventional dehumidifier would have been consuming. This machine is going to save almost about 4 lakh rupees per annum for the client and 6.5 kilowatt of power consumption. Now, how does it work? Come, I'll explain you the principle of what it's working. It's working on a very simple refrigeration cycle. More you cool the air, more is the humidity which is removed from the air. Now this is drawing in fresh air from here, the ambient air from here. Whatever might be the temperature, whether it is summer, monsoon, winter, is going to be taking in 100% fresh air and then treating it in 2 cooling coils. What you see here, there are 2 condensing units, condensing unit 1 and condensing unit 2. What you see here, this box is the cooling coil 1 with all its expansion kit. Then what you see here is a cooling coil 2 which is cooling the air, subcooling the air. And again behind this what you see is the complete expansion kit, the capacity modulation kit which has been integrated into the system design. Then what you see here, this is the hot water coil which is generated from the waste heat. Whatever you are seeing in the condenser here, this condenser heat normally is dissipated into the atmosphere. Now in our engineering, what we are doing is we are using this heat to generate hot water. This hot water is used with the help of a modulating valve to control the temperature of the air to anywhere between 30 degrees centigrade to 50 degrees centigrade. Because the hot water we can have till 55 degrees centigrade in these machines. These machines are designed to give you 55 degrees centigrade temperature. But please note, this energy of the condenser heat which we recovered is absolutely free of cost for you. Now when you come on this side, we have seen there is a cooling coil 1 which cools the air in step 1. Then this cooling coil 2 further cools the air in step 2. It cools to the temperature which you want to cool. Maybe it is 2 degrees centigrade, maybe it is 5 degrees centigrade, depending on whatever dew point you want to achieve, whatever temperature you want to achieve, whatever RH you want to achieve. This particular coil is designed to give you that temperature. Then heating, as I said, we can heat it from 30 degrees to 50 degrees or 55 degrees centigrade. This heating is going to be absolutely free because when you heat air from 2 degrees centigrade to 50 degrees centigrade, that consumes a lot of energy, my dear friends. This comes absolutely free of cost from the wonderful system of heat pump cycle which we use in this application. Now we'll take you to the actual performance of this machine. This is the PLC. If you can focus on this PLC, see this 30 degrees centigrade temperature which you are seeing here is the ambient temperature. This 6.6 degrees centigrade what you are seeing here is the cooling coil leaving temperature. This 31.7 and 22% RH what you are seeing, this air at 6.8 degrees centigrade in this system design is to heat the air till 31.7 degrees centigrade and reduce the RH to about 23%. What you see here, this 41.8 degrees centigrade, what you're seeing here is the hot water temperature. This can go till 55 degrees centigrade, but since in this particular case we required temperature of the air to be heated only till about 31 degrees centigrade, that's the reason we have just kept it to about 42 degrees centigrade. We don't need to heat more, but these machines have the capacity to heat the water till about 55 degrees centigrade. Now, when you come on this side, this is the power panel which is there. This power panel has all the contactors and whatever is electrical hardware which is required for the machine. Then this is the access panel side, where we can open up this door and clean the cooling coil. We can open up this door, we can clean the cooling coil plus the hot water coil, because for a successful operation of the machine, cooling, coil cleaning and filter cleaning, hot water coil cleaning is very, very important. Now when you see here, this is allowing the air to be drawn in for the air-cooled condensers which have been installed in the system. And when you come this side, this is the hot water tank. You can see the water is till this level at this point of time. Here, this particular nozzle is used for feeding in water. This nozzle, what is shown here, is for draining out the water. When you want to drain out the water, you can just open this and remove the water and change the water. See, all these panels are openable. You can open up at any given point of time, so that you can have proper servicing, you can have access into the machine. Now if you see this drain fan, this condensate water is coming in, this is getting drained here. Okay, this will be connected to the drain point, and the machine is working, is giving you the cooling, and it is also controlling your RH. So this in principle can be used for drying chambers, this can be used for humidification or the dehumidifier, this can be used as a TFA. In this particular case, it is being used as a TFA, that is treated pressure unit. Here you control temperatures, you control RH to the level what you want to plan or what is required in the design. My dear friends, this is a wonderful machine, consumes almost 48 to 50% less power compared to conventional dehumidifiers and saves a lot of operating costs. Thank you very much.